Welcome to everybody. Welcome back to the Open Data Hack powered by Filecoin. As I said, it's really great to see you all here again. I'm seeing lots of people in the chat who I recognize, so it's amazing to see the community coming back together once again. I do hope you all enjoyed the launch event with Clara yesterday. The recordings for that will be available very shortly. So if anybody wasn't able to attend or wants to recap any of the bounties, you'll be free to do so shortly after this call. But yeah, I just encourage you all to make sure you join the Discords. You can reach out to me on Discord. You can reach out in the technical channels to ask any of your questions. And yeah, it would be great to see you all interacting in those servers. Also, I'll drop all the links in the chat once I hand over, but the Hacker Pack, again, is a really great place for you to go to get any information you need for the hackathon. And often any questions you might have, the answers are already in that Hacker Pack for you. So as I said, once we get started, I'll drop all the links for that in the chat and you should have those ready to access. But that's everything from me. I'd love to just highlight that we do have lots of workshops coming up. We have 4 today. They'll all be in this channel. So do feel free to sit around. For those, you don't have to leave and join. And we'll just carry on into those after this talk. But the future workshops will also cover some more basics of Filecoin and FVM. So even if you don't manage to follow every step of today's workshops, you're welcome to attend the later sessions, the basics, and then you can revisit these recordings at a future date. So Xiangan, I think that's probably enough from me. I'd love to hand over to you. So feel free to share your slides and kick things off.
Sweet. All right. Well, first of all, thanks again, everyone, for being here. I really appreciate all of you having attended and taking your time. I'm Xiangan. I'm an engineer over by Protocol Labs, and I wanted to show you all today a cool little thing that we've been building over here for you, the Renew, Repair, and Replication Starter Kit. This is very exciting because I can literally take any file that you guys have, anyone out there, if you have like a favorite pet that you want to immortalize, or you want to just do something like that, and you want to have permanent, decentralized, unbreakable, immutable storage for your data, then this is the right place. This is where you can get that done. So there's a few components to this, but before I get into that, I just wanted to, first say hi again to the chat. I saw someone say hello from Nigeria earlier. So I'm really, really excited to just see all of you and have all of you come in from various different corners of the world. Hi from Egypt. Awesome. And yeah, just keep the highs, keep the energy rolling as we continue barreling through this workshop. So, like I said, there's a few components to this. When you're there's the developer, there's the smart contract that you can deploy. There's a node that listens to events on the smart contract to sort of help you repair and handle your data. There's also another aggregator backend to the node that allows for the actual completion and the verification of the data that you upload onto the chain. So I'll just walk through this, the usage, and what exactly is a step-by-step via the code repo that we have. You all can visit the RaaS starter kit over by the Filecoin project if you want to follow along. I'm just going to post this link in the chat for all of you. That way you guys can follow along if you want. But this is the repo. Everything is on main. All you have to do is just copy this link and then git clone, and then it'll produce a clone of the repo. And then you're going to want to just do your usual npm install to install your dependencies. And there's a few other things in this repo that makes it easy to interact with, such as existing Yarn scripts. This is also in the README, so if you don't follow along, you can read that later. But all you have to do to actually get this whole service started is Yarn service, which will spin up the node that you have in the backend that is supposed to basically store your jobs and then keep them maintained. It's like if you upload a picture of your dog and you want your node to take care of it, keep it well fed and well watered. This is the node, like the Yarn service. It's going to be there to take care of everything. And then the front end website that you can sort of like interactive interface that you can interact with is located right here via a command called yarn start. Here you can upload a file, and then once you upload the file, it will provide you with a content ID. When you upload the file, you create an instance of the file on the Filecoin network for everyone to maintain and to basically have this decentralized file storage. But where this is interesting is where you start wanting to register the various repair, renewal, and replication workers. These workers make sure that your file is immutable it makes sure that it's maintained. It's maintained so then it doesn't break and it doesn't expire, let's say, so that you have actually permanent data storage that is doesn't just rely on one failure point, because whenever you replicate, you can replicate to as many nodes as you want, and make sure that those are being actively proven via this repair job. Basically, making sure that they're active on the network, ready to go for retrieval whenever you want. Okay, so let's walk through the actual interactive steps of this a little bit, shall we? So I can just literally upload, let's see, any random file. I'm just gonna upload a picture of myself. All right, let's upload a picture of myself. If you click upload, it'll say upload complete after a little while. And what this actually specifically does is there is a sort of just a really basic front end scripts and HTML file in public. And whenever you click the upload button, it actually sends a API request to the node service that we just booted up. So, booting up this node service via Yarn service is a prerequisite. So once that's done that, specifically what it's doing is, let me just search up the function for you. Yes. So this specifically uploads a file to an aggregator, a data aggregator called Lighthouse. What Lighthouse does is it basically just acts as a data storage solution for you. And so when you upload the file, it'll provide you with that content ID or CID that we were talking about earlier. There's a little bit of a description here about what specifically this CID is, but all you'll have to do is just basically if you don't upload your own file and if you want to just test to see what's going on, you can always just press tab on this little box. It'll enter in a sort of filler CID for you that's been tested to make sure that it works. But we can also just go do it live. We can register the job. It'll say that it's has been registered. The CID has been registered with the smart contract, and it's awaiting a response from Lighthouse. And specifically, what's going on now is what we have in the code is when you submit a file, the CID of a file, it has the CID, which is exposed to you, and a lot of other certain sort of default inputs. These default inputs determine, first of all, the type of job that's being run. By default, all three jobs are being ran, so then your files are continuously renewed if basically the deal to store the file expires. It replicates to a certain number of replications to make sure that there's no single failure point, and it repairs the file if it's broken. you can choose any of the individual jobs to out of those three to run at your own leisure. There is a specific end date to you wanting to run the job. So let's say if you want to, immortalize your job or your data for like 3 months, and then you don't really care about what happens after 3 months. This is the end date. But of course, this end date can be arbitrarily large, which is why you can sort of keep your data on the network renewed and repaired however long you want. And of course, for the aggregator, we have Lighthouse. Previously, we had support for multiple aggregators, but Lighthouse was the recommended solution. Therefore, for your smooth user flow, we decided to default to Lighthouse. And so now that you've submitted a job, what specifically happens? When you submit a job, you submit the content ID of the file that you get from the file upload to a smart contract. The smart contract is right here, and the smart contract is important because it basically stores on the Filecoin virtual machine, basically on the blockchain, the various proofs that the file has been included on the network with regards to the CID, whatever CID that you stick in. So when you call submit, it increments the transaction ID, saves the CID, and it emits an event. This event gets picked up by the node to do further processing on the data. Of course, you can build on top of this, this deal status contract by simply inheriting from the iAggregator Oracle interface via something like, just basically import it, and then you say is, iAggregator Oracle. And then you can build your own implementations of whatever these getters are. These getters currently are sort of just mostly boilerplate. You're going to need these getters for the various jobs that we had just mentioned, in almost every case. However, you can also build in additional sort of incentives. So, for example, I don't know, if you want to get like a tokenomics system going and you want to mint your users some sort of reward for uploading specific types of data or data with specific CID, you can do so via this submit function. So basically just changing the submit via, let's say check data integrity or and then you put some sort of check on this CID. And of course, you're going to want to do I don't know, some sort of replay checks, right? So then, people don't just submit the same CID over and over again and get rewards. And so this is the kind of stuff that you can do. You can build on top of this deal status interface or basic deal status contracts and build your own unique applications through it. And and then all you have to do to actually put this into production or staging is a simple thing called yarn deploy calibration. So we've as for the yarn scripts thus far, we've gone over 3. So yarn service to actually start up the backend node that will help you be able to interact with the front end. Yarn start after yarn service to have the front end, and last but not least, the yarn deploy calibration that I just mentioned. And then it'll just when you run this, it'll deploy your thing for you. And of course, I'm not going to show my .env file because again, it's private, right? But we've included a .m.example file that includes all of this various mumbo jumbo. So then you can have this sort of setup, the environment setup that you need. All you'll need to do on your end is just fill in your private key. And of course, this is like local file storage. You don't commit this onto GitHub. And it won't, it won't screw you up or anything like that. Okay. Well, so, now that the file has been processed a little bit more, let's explain and sort of go through what just happened while we were just talking about the other components of the starter kit. So thus far, you've seen the contracts component and sort of the entry point into the service submission. And now, there's a lot of basically, logs that happen. So what exactly is this, right? So first of all, when you upload your CID into the contract and then the contract emits that event, our node has a event listener to actually catch that event. So it should be right around here. So it basically starts a event listener. It handles the event by sending it to the Lighthouse aggregator.js for processing. And what specific processing does this happens? You might ask. Well, it downloads the file again off of the CID, just in case if you uploaded a CID where you didn't upload the file. So if you have any arbitrary CID and then you just stuck it into the box without actually uploading the file in the first place, and it's a known CID, like if you previously uploaded it to Lighthouse, then that it'll fetch the file for you. That path still works. It'll enqueue the job and it'll store the file and then try to upload the file and make a deal with the Lighthouse data aggregator, which means you're telling the data aggregator to store your data, and it'll try to do so. This process may take, the actual process of the data aggregator storing data may take a long time. In testing, it has taken as long as 12 hours. Therefore, you don't need to keep your node open for all this time. If your node happens to shut off, or if you want to go take a break, walk your dog, eat your lunch, whatever, you can restart it via that job enqueuing and saving mechanism. It'll try to read from these cache files as sort of like the state that gets saved as it runs. So now that we've processed the file and sent it over to Lighthouse, what exactly are we doing with Lighthouse? Well, we are sorry about that. We are creating, first of all, these deal parameters. These deal parameters specify which miner on the network you want to basically take care of your deal, as well as sort of various other default settings regarding whether or not if you want Lighthouse to actually run your renew and repair and replication of services. And so here it's important to actually distinguish that while we have a specific starter kit here for these renew, replication, repair services to keep your file permanent on chain, Lighthouse also has a service that they hosted on their own. This starter kit is just to make sure that you can run these services on your own as well, to encourage maximizing decentralization. And in case if their services go down, you can still sort of have these jobs ran on your own. And of course, the network that you want to go on. Currently, we have the network set to calibration, and just a miner that we've tested with and relied on that works. And so with these deal parameters, all you have to do is just stick them into the upload. Here we use lighthouse.upload because we're using the Lighthouse SDK, but you can use any other tool or aggregator here instead of Lighthouse. And you'll get back the CID, which in turn you can use to start querying the deal status. So when you submit a deal, a CID onto Lighthouse, you're gonna have to wait for the deal to complete, which means continuously querying this deal infos endpoint for like I said, up to 12 hours. And once that process completes, and the whole thing about uploading the CID it basically succeeds on Lighthouse's end, it should provide you with a with something similar to this. So this is like you have this PCID, which is the content identifier on the Filecoin network. You have the proof that the data was stored, as well as various information about the deal, the deal that was made that stores the file on chain. So it'll say, oh, Lighthouse deal info process after receiving non-zero deal ID. And then it'll complete the deals for you. And what do I mean by completing the deals? Well, when you actually receive the deal proofs, you're going to want to store that on chain, because that's how you have a sort of immutable proofs that this data was indeed stored onto a aggregator at one point in time. So there's another event listener that listens to the deal received event that gets emitted by one of these aggregators, and it will try to complete the deal for you. That's pretty much it. Once the deal has been completed, it gets stored into one of these like service state cache files for loading later on if you again shut off your computer. But it also gets enqueued onto the active jobs list. That means the node will then start running the actual jobs. So it'll say executing jobs, processing all, and then it'll try to start replicating and renewing and basically doing all of the jobs that it's supposed to do. As you can see, it had zero replications earlier. Now it has 3 replications, which means that your job is now stored across 3 different separate minor nodes on whichever network, calibration, or mainnet that you've chosen to deploy your application on. It'll just continue to keep to do this unto perpetuity, until the end date of your deal. And so if of course this currently I've set the sort of iterative time to actually execute these deals to 50 seconds. And so it's not very long. You should increase the standard time that's sort of expected for this is 12 hours. You renew and replicate and whatever every 12 hours to make sure that the node doesn't run, or the service load isn't too much. You don't continuously always resubmit deals onto the network, and it'll just it makes sure every 12 hours that your job is still fine. That way you get to maintain all of your jobs. So that's basically the end-to-end flow. Today what you did was basically go through all of these various different components that you need to start setting up immutable and permanent on-chain storage. And I don't know if this is cool, but I always think that it's pretty cool that all of this stuff that we just went over, the stuff that I just spent 20 minutes blabbering on to all of you about, all of the difficulty of that gets abstracted away by just a simple front end. Literally, all the user is concerned about, at least for your app, is just uploading a file, and then it'll automatically populate the CID, and all you have to do is just click deploy, and it'll tell you when it's completed, and even give you a link to show you that the deal has been indeed stored on chain. So this is the calibration net sort of deal, or calibration net explorer. Sorry, and you can indeed see that the deal was stored, and it's a verified deal, and it's on chain. So I think this is pretty great. There's a lot of different components about this though, so I want to go ahead and try to make some time for Q&A in the chat. And also, of course, say hi to everyone. Hi from again, hi from Nigeria, hi from Missouri. I'm in Boston, so hi from Boston. Let's see. Oh, just curious, how does it repair the file? So let me maybe explain a little bit of the semantics with regards to what exactly happens to trigger these various jobs. Also, just let me maybe zoom into the code a little bit so you guys can read this a little more carefully. But the code for actually executing the various jobs is found within these execute blank jobs functions. The replication deals happen when there is the number of active deals on the network is less than what you've specified. The smart contract has a function that returns the amount of active deals for a specific CID on the network, which is why I said most of these various getter functions are boilerplate and are necessary for the various jobs. And so once it checks that, if there aren't enough, replications, it will try to get to that point by resubmitting the deal on chain and then basically proceeding through that process over and over again until it does achieve the number of replications required. Renewal is similar in the sense that it's a sort of counterpart to replication, where it will check for the number of expiring deals, and if there are any expiring deals, it'll try to resubmit and basically replace the expiring deals. That's what we mean by renew. The repair job is the most complicated of all three. And specifically, the repair job checks to see, so it gets all the deals currently involved with the CID from the smart contract. It will then check to see whether or not those deals are actively being proven within basically a given, various sectors on the Filecoin network. And so it basically just calls this, Filecoin.state market storage deal method, and it will check to see if the sector start epoch is greater than -1, which means that it's going. The slash epoch is not -1, and that the current block height is greater than minus the slash epochs is greater than the epochs that you've specified. And again, specifically, what this means in layman's terms is all of these conditions check to see if the file is being actively proven on the Filecoin network. If it's not, if it's broken, if it's getting slashed, and specifically what I mean is if a storage provider fails, or if a node fails, data storage solution fails, right? Then this event will trigger, and it will then just resubmit the deal onto the network, and then create another instance of the deal to replace the broken deal with. TLDR, if the deal's broken, it'll try to repair it. But this little condition check happens if your storage provider is broken. I hope that helps. Let me know if it doesn't. Can we set param where geographically where it's stored? I don't think so, not yet. So that's why you need, well, first of all, that's why you need two things. Different aggregator hosting locations via just literally having different aggregators on the network, and having your own self-hosted RaaS, services, right? If you self-host your service, you can have your RaaS service wherever you want it to be, instead of having to rely on the specific geographical location of wherever the data storage provider is. And of course, the storage provider, there should be multiple storage providers on the network, but at the moment, parameters wise, unfortunately not.
So sorry to say, but I think that might be all we have time for, given that we've just got a minute or two to wrap up. But I have actually dropped a link to the FVM Discord zone in the channel here. So if anybody does have any more questions, I'd encourage you to use that zone there on Discord, and I'm sure one of the team would be happy to get back to you. But just on behalf of everybody here, I'd love to say thank you very much. Incredibly interesting session. Clearly something you're extremely passionate about as well. So it's great to hear you talk some more on that topic. But yeah, I don't know if you have any final remarks or anything you'd like to share, but thank you once again.
Yeah, sure. I mean, of course, a final remark. I just want to answer one last question from Saksham. That is a pretty great question. So when you upload the CID onto the smart contract, that's obviously that's just uploading the CID, right? For the actual uploading onto the file, though, it goes toward a data aggregator that is not necessarily just a centralized backend server. What the aggregator does is specifically, it's basically just you can think of it as a wrapper to upload data onto the Filecoin network. Ultimately, your data still lives on Filecoin, and it is retrievable via Filecoin. The aggregator is just an SDK for you to basically make that happen. You'll hear, I mean, you can ask more questions if you're curious about the aggregator tomorrow. One of my colleagues is giving a talk about that, the aggregator, the Lighthouse aggregator specifically that we use today. So some folks from over there will be better able to answer your questions. But yeah, thanks a ton for coming, everyone. Really appreciate your attention, and hit me up on Discord if you need help on the hack. And best of luck to everyone.
Amazing. Thank you so much. Thank you to all the participants as well for your incredible questions. But yeah, thank you very much for that one.